In this video, we will be looking at how to write a loop. Here are the subgoals for writing a loop. First, we determine the purpose of the loop. Then, we pick a loop structure, while, for, do while, based on the purpose of the loop. For subgoal 2, we define and initialize the variables. For subgoal 3, we determine the termination condition. Then, we invert the termination condition to form the continuation condition. For subgoal 4, we write the loop body. We update the condition to reach termination. We also make sure to change the loop control variable somewhere within the loop. We want to write a loop that will prompt the user to continue to enter numbers until a sentinel value is entered, and find the maximum value of all the values entered. For subgoal 1, we determine the purpose of the loop. In this example, we want the user to enter values until a sentinel value is entered. When using a sentinel value, we usually will want to use a sentinel loop. Generally, while loops are a good choice for sentinel loops. Notice the comment stating we need a sentinel loop, which means we need a sentinel value and have a priming read before the loop begins. The loop should prompt the user for values and find the largest value. For subgoal 2, we define and initialize the variables. We are reading in values from the user, so we need a scanner. We are going to read the values into an integer variable called value. We need to store the maximum value, so we declare a variable called maxSoFar. Then, we have our prompt to the user, followed by our priming read statement, where value is assigned the scanner's next integer. For subgoal 3, we define the termination condition. In this case, we want to continue reading values until a sentinel value is entered, so we need to pick the sentinel value. The sentinel value needs to be the same data type as what we are reading in, so in this case, it needs to be an integer. It also needs to be a value that is not readily occurring in the data we are reading. We also need to tell the user what the sentinel value is. Here, we choose the value -1. We anticipate the user will only enter values from 0 and beyond, and we want to find the maximum value. So the termination condition will be when the user enters the value -1. Now we invert that to create the continuation condition. We will continue the loop as long as the value read in is not -1. For the first part of subgoal 4, we update the loop control variable to reach termination. This is another read statement, where we prompt the user to enter in a value, and we are reading that next value. Now we write the loop body. We want to test if the value read in is bigger than the maximum value we have so far. If so, we want to replace the maximum value with the new bigger value. Our loop now says, read in a value from the user. As long as the value isn't -1, go through the loop. If the value read in is bigger than the value of maxSoFar, replace and store the new value as maxSoFar. Then read in another value. Continue to read in values until the user enters -1. When the loop ends, if the value of maxSoFar is greater than -1, we know we entered the loop at least one time, and the user entered something that was not -1 and greater than -1. If maxSoFar is less than -1, we assume that no values had been entered. Now let's look at another example. Here, we will write a loop that adds up the values 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16, all the way until we reach 1 over 1024. For subgoal 1, we determine the purpose of the loop. Here, we have a summation loop. We know how many times we will go through the loop, so this could be a for loop. But for now, we are going to write this as a general purpose while loop. Next, we define and initialize variables. We need one variable for the sum and another variable for each term. We probably want the sum and the term to both be doubles so that we don't end up with integer arithmetic and a bunch of zeros. Now we need to determine the termination condition and then invert it. We want the loop to stop when the term has processed 1 over 1024. In this problem, the denominator rises in powers of 2. 2 to the 10th is 1024. So we know that this loop is going to add 10 exact values. So, as long as I is less than or equal to 10, we will continue in the loop. To write the loop body, we need to add the term to the sum. Then, we need to calculate the next term by multiplying the current term by 1/2. So the loop looks like this. We initialize sum to 0, term to 1.0, and I, our loop control variable, to 0. While I is less than or equal to 10, sum is equal to the sum plus the term, and then divide the term in half, increment I. At the end, we print the sum.